Welcome to All This Math. This is Professor Parker, and today we're going to be doing some work with graphing quadratic equations. Okay? Now, before we get started, what I want you to think about is the fact that when you graph a quadratic equation, or when you really graph any equation, essentially what you're doing is you're drawing a picture. That's really all it is. You're drawing a picture, except there's a set of rules to how your picture should look based upon what the equation looks like. Now, one thing to keep in mind, too, is how do I know that this is a quadratic equation? Or how do I know what my graph's going to look like? Well, I should say, you know what your graph's going to look like or what kind of shape it's going to be in based on what type of equation it is. Now, this is a quadratic equation. You know that it's a quadratic equation because the biggest exponent that you see is a 2. Okay? The biggest exponent you see is a 2. So I know this is a quadratic, right? Because it's a quadratic, it's either gonna be shaped like what's called a parabola, right? A parabola, right? Which means that it's gonna either go like this or it might go like that, right? Okay? It's not gonna be sideways based on the way this equation is set up. I'll do some videos and you'll see examples where the parabolas will be sideways, but we're not going to see that tonight. All right. So, getting back into it. We know this is a quadratic, so we know our graph is going to be a parabola. All right. And we want to basically just kind of take an inventory of some basic information about this equation that we can tell from this. All right. First thing we can say is it going to open up or is it going to open down? Is it going to open up or is it going to open down? Right? Now, this is how you tell. If this is in standard form, which it is, because we have x squared, well, really ax squared plus bx plus c, right? That's what we refer to as standard form. All right? That's standard form. The value of a tells me if it's going to open up or if it's going to open down. Now, in this case, my a is positive 1, because remember, if there's no number written as a coefficient, then we just understand that to be a positive 1, right? It's a positive 1. So let me just write that down so you can see it. A equals positive 1. Now, because a is positive 1, that tells me that my parabola is going to open up. Like that. All right? It's going to open up. That's important information. That's important to know. All right? Next thing I want to know is, well, if it's going to open up, what's my lowest point going to be? That lowest point is called the vertex. The vertex. You always want to know what your vertex is, whether it opens up or it opens down, right? Your vertex. So this is how we're going to figure out what the vertex is. The vertex is a point. The vertex is a point. And of course, every point has a x coordinate and a y coordinate. Now, the first thing we'll figure out is what the x coordinate is. Now, there's a small little formula for that, right? It is x equals negative b over 2a. X equals negative b over 2a. We use that formula to figure out the vertex when the equation is in standard form. Now, if it's not in standard form, it will be in vertex form. So we wouldn't need to use a formula to figure out what the vertex is, because when you see examples in the vertex form, you're going to be able to look right at it and tell what the vertex is. Just like with linear equations, the straight line drawings, when you look right at it, you could tell, like in slope-intercept form, you could tell what the slope is and what the y-intercept is just from looking at it. All right? So now let's figure out what negative b over 2a equals. Now, first of all, what is b? B is this number right here. B is the coefficient of x. Just like a was the coefficient of x squared. B is the coefficient of x. But this is one thing that a lot of people get caught up on. They say, oh, well, the formula has a negative sign in front of the b, but b is already negative. So cool. So we don't got to put 2 negative signs. Yes, you do. You have to put the 2 negative signs because the formula is telling you that you need to take the negative of whatever b is. So if b was positive, you're taking the negative of a positive number. Since b is negative, you're taking the negative of a negative number. You got to do that. So it looks like this. Over 2 times, and we already told you what a was. A is 1. So we do our simplification now. Now, double negative becomes a positive. So that's going to be positive 6 divided by 2 times 1. 2 times 1 is just 2. So positive 6 divided by 2 gives me 3. So that's the x value of my vertex, right? So for my vertex, I know I got a 3, and I know I need a y value, right? Because every point has an x and a y value, right? Okay? So I know I got my 3. Now, the way I figure out what y is I'm figuring out what y is when x is 3. So that means I go back to my original equation, right up here, original equation, and I do this. I say, okay, well, y equals, I replace all the x's with 3's. I'm going to replace all the x's with 3's, right? So I'm going to have 3 squared minus 6 times 3 plus 5, right? And I'm going to just do my math, right? I'm going to just do my math using order of operations and just calculate correctly. So 3 squared is not 6. Remember that. 3 squared is not 6. 3 squared is 9. And then I have 6 times 3. So that's minus 18 plus 5. So now we do our subtraction and our addition. 9 minus 18 is negative 9. Negative 9 plus 5? Negative 4. Negative 9 plus 5 is negative 4. So now I know the coordinates of my vertex. All right, so I'm getting close. All right, now there's something else that you should figure out when you're going to graph a quadratic. It's called the axis of symmetry. The axis of symmetry, right? Now what an axis of symmetry is it's a line on the graph that basically cuts the graph in half. It cuts the graph in half. So you know you have just as much information on the right side of that axis as you do on the left side of the axis. Sometimes the axis of symmetry is the y-axis. So that means you don't have to draw one, right? Sometimes it's not. Sometimes it could be something over here. It could be something over here. It could be something all the way over here, right? But the axis of symmetry is just the vertical line that goes through the vertex. It's the vertical line that goes through the vertex. So I like to just call it AOS, axis of symmetry. So the actual axis of symmetry, because remember, from before, when we was graphing straight lines, right? When you have a vertical line, that means the way you describe that vertical line is you have x equals the point on the x-axis that line goes through. So if my vertex has coordinates of 3, negative 4, and it goes through the vertex, that means it's got to go through positive 3 if it's a vertical line. If it's a vertical line and it goes through this point, that means it goes through positive 3 on the x-axis. So right over here, right here, this positive 3. If that's 0, then this will be 1, 2, 3. If my scale is 1, which it will be, you know. So my axis of symmetry is x equals 3. Because remember, when we name a straight line, well, when we name a vertical line, the vertical line is x equal to a number. There's no y value. It's just x, a equal sign, and a number. X, a equal sign, and a number. That's it, right? Now, sometimes what we need to do is we need to create a table of values, right? So we'll know actually where we're going to draw our parabola, right? But other times we could do something else. We can figure out what our x-intercepts are. Sometimes there's only one x-intercept. Sometimes there's 2, right? The x-intercept, again, is the points where the parabola is going to touch the x-axis, right? Here's the x-axis. Like, where's it going to hit it? Is it going to hit it twice? Is it going to hit it once? Is it not going to hit it at all? Let's see. So let's find the x-intercepts. All right. So to find the x-intercepts, what do? Remember the definition. Always remember your definitions, right? Some definitions don't change regardless of what type of function or what type of graph we're looking at. The x-intercepts are the values of x when y is 0. They're the values of x when y is 0. So all I got to do is replace y with a 0, and then I solve for x. So 0 equals x squared minus 6x plus 5, right? Now we got different ways that we know how to solve quadratic equations. We know how to factor. We know how to use the quadratic formula. We know how to complete the square. We know how to use the square root property, right? Sometimes. But factoring is usually the most easy and the most efficient, right? Sometimes we can't factor though, but we should always try. So I look at this trinomial. I'm looking at it, I'm like, okay, I wonder if I can factor in. Let me see. I know I can. Check this out. Because I could break this down into two binomials. The x squareds break down into x and x. And I'm going to put an x right here and an x right here. Now, this is what I like to call the reverse FOIL method. If I can find two factors of 5 that add up to -6, then I'm in business. I'm good to go. So I know that -5 times -1 equals +5. And also -5 plus -1 equals -6. So those are my two factors. And that's one of the methods of factoring. I got some other videos on factoring if you need to brush up on those skills, right? Because that's critical. Knowing how to factor is critical. When you come to the table, you got to already kind of know that. You got to know how to factor so you can do this work. All right. So I'm going to do -5 right here and -1 right there, right? Equals 0. Now, of course, zero product property. Each of these is a factor. So therefore, each of these can be used to create an equation, right? So I could write x minus 5 equals 0. That's one of my equations. X minus 5 equals 0. Then I'm going to solve for x. And then I'm going to write x minus 1 equals 0. And I'm going to solve for x. Now, if x minus 5 equals 0, then I know x equals 5. That's one of my x-intercepts. That's where my parabola, my drawing, my work of art that I'm about to show you in a minute, is going to cross the x-axis. And if x minus 1 equals 0, then I got x equals 1, right? That's my other x-intercept. All right? Now, let's talk about the y-intercept. One thing that I'm going to tell you is that when your equation, your quadratic equation is in standard form, your y-intercept is always the number that we call c. So this is c, right? Because it goes like this, right? In general form, it's ax squared plus bx plus c, right? The y-intercept is always going to be c. So make sure you put that in your notes. Make sure you memorize that. It'll save you a lot of time. So I'm going to say right here, y-intercept is 5. Now, what if you don't believe me? What if you think I'm lying? Okay. By definition, the y-intercept is the value of y when x is 0. So if I go up here and I replace these x's with zeros, what's going to happen? 0 squared equals 0. Minus 6 times 0 is 0. So 0 minus 0 plus 5. What's 0 minus 0 plus 5? It's 5, right? Exactly. So believe me when I'm telling you, right? The y-intercept is always going to be the c value when you're in a standard form of a quadratic equation. All right? So it looks to me like we got enough information to do what we got to do, right? We wanted to graph this. We know what the parabola looks like. You know what I'm saying? Let's do a recap. Okay. I know what the parabola looks like. I know it's going to open up, right? It's not going to open down. It's going to open up. I know that because my A is positive, right? I know what my vertex is, so I know the bottom point. It's like being on a roller coaster. If the roller coaster start up here, it drop, it hits the bottom point, the lowest point, then it starts to go back up, right? The vertex is that point where it stops going down and starts going back up again, right? My x value is 3. My y value, we figured that out, was -4. That's my vertex right here. I can plot that. My axis of symmetry right here. I really don't need the axis of symmetry because I got x-intercepts, but if I didn't have x-intercepts and I was using a table of values, then I would use actually, no, not even the table of values. I would use the x-intercept to figure out what my other points were. Because if I find a point on the left side, then I know I can just use the axis of symmetry to say, okay, well, cool. If I got a point over here, right, like right there, there's going to be another point on the other side of the axis of symmetry that's just as far away from the axis of symmetry. That's how the axis of symmetry can help us to draw our graph. That's how it can help us. All right. So now let's get busy with this graphing. All right. So let me first plot my vertex, 3, -4. So I'm going to go 0, 1, 2, 3. I'm going to go down 1, 2, 3, 4. All right. That's my vertex. Right. And then I'm going to just draw my axis of symmetry. Draw my vertical line like this. All right. Okay. Now, then I'm going to draw my y-intercept, which is 5. So I go 0, 1, 2, 3, 4, 5. Boom, like that. All right. And then I'm going to plot my x-intercepts, +5 and +1. All right. So I'm going to put +1 right here. And then we go 2, 3, 4, 5. right there, right? And then I'm going to draw my parabola, right? It's going to look like this. Boom. That's my parabola. So we had to put in the work and do this leg work, find the vertex, find the y-intercept, find the x-intercepts in order to be able to draw this. Okay? I got my x-intercepts right here and right here. That's my axis of symmetry. It goes through my vertex. My vertex is right there. And my y-intercept happens to be right there. All right? So this is basically how we graph a quadratic. Let me slide over here in case you want to look at this, right? I like this. This is my work of art. I like this right here, right? So yeah. So in case you want to, take a look at that. So this is how we do it. This is how we do it. This is how you graph a quadratic equation, right? You find the information that we just found, and then you just plot your points, and then just relax, just imagine you chilling, you're in an art class, you just laid back, you just plotting points. You know what I'm saying? This should be stress free. This should not be a stressful thing, right? We just chilling, just doing some algebra, and just drawing some pictures, drawing some parabolas. That's all we're doing. All right. Well, if you learned something, as usual, please like the video, subscribe to the page, tell somebody about the video, share it. Don't be selfish. Don't find out about this and try to keep it to yourself. Share this. Let people know about it. All right. And remember, there's all this math all around you. Peace.